Hello, and welcome to Math with Zach. And today, we're going to be talking about limits. Sadly, math is boring, but here we go anyway. A limit is defined as the value that a function or sequence approaches as the input approaches some value. Limits are essential to calculus as they are used to define continuity, derivatives, and integrals. But remember, here on Math with Zach, the sky is the limit. Now, we're going to send it back to Zach at the studio. Zach?
Welcome back to the studio. Now today I'm going to give you 5 examples of limits we are working out of the Applied Calculus book for UWO, the custom published for Math 0110. And I'm in section 3.1 and I am going to be doing question 39, 40, 50, 51, and 60. So we're going to start with 39, which is find the indicated limit. So as you see, as I have on the whiteboard, you have the limit as x approaches -1 is the square root of x squared plus 8 over 2x plus 4. So the first step that you're going to do is substitute -1 for x. So your new equation would be, as the limit x approaches -1, you'll have the square root of -1 squared plus 8 over 2 -1 plus 4. So what you're going to do now is you're going to take the square root of -1, which is 1. So now you have the square root of 1 plus 8 over -2, because 2 times -1 is -2, plus 4. So what you're going to do next, as the limit x approaches -1, the square root of 1 is still 1, so you're going to have 1 plus 8 as -2 plus 4 is 2. So as the limit x approaches -1, your final answer, 8 plus 1, is 9 over 2. So therefore, the limit is 9 over 2. Okay, so on to question 40, we're asked again to find the indicated limit. And the question is, as the limit x approaches 3, your x times the square root of x squared plus 7 over 2x subtract the square root of 2x plus 3. So we're able to just substitute 3 back into the equation to find the indicated limit. So as the limit x approaches 3, you put 3 times the square root of 3 squared plus 7 over 2, and that's just the fancy sign for multiplication, times 3, subtract the square root of 2 bracket 3 plus 3. So 3 squared is 9, so 3 times the square root of 9 plus 7, and then over 2 times 3, subtract the square root of 9, because 2 times 3 is 6, plus 3 is 9. So the next line would be, as the limit x approaches 3, so the square root of 9 is 3, so now it becomes 3 times 3 plus 7 over 2 times 3, subtract 3, because on the bottom the square root of 9 is also 3. So now it becomes, so 3 times 3 up here, so as the limit x approaches 3, it now becomes 9 plus 7 over, and then 2 times 3 is 6, so 6 subtract 3. So you do the adding and subtraction, so 9 plus 7 equals 16, 6 subtract 3 is 3, so as the limit x approaches 3, it will be 16 over 3, so therefore the limit is 16 over 3. Alright, so we're on to question 50, and on this exercise we are supposed to find the indicated limit if it exists. So this question, we're on 50, it's a little more trickier. So the question asks, the limit as x approaches -2 is x squared subtract 4 over x plus 2. So as you can see on the whiteboard, if you put in, if you substitute -2 into the equation, you would now get -2 squared subtract 4 over -2 plus 2. So -2 plus 2 is 0, and then 2 squared is 4, so it'd be 4 subtract 4 over 0. So it equals 0 over 0, which is sad. Now, what you need to do is you need to interrogate the function. It is hiding its answer. It's good at hiding. It does not want you to know its actual value. So as you can see, x squared plus minus 4 is indeed difference of squares. So as you can see, you can do x plus 2, x minus 2 on the top, which when you FOIL out is x squared minus 4, and all over x plus 2. So you're able to cross out 2 of the x plus 2's, so you're just left with x minus 2. So as the limit x approaches -2, you would now sub in -2 into your new simplified equation. So -2 minus 2 equals -4. So as the limit x approaches -2, your limit will be -4. Alright, so now we are on to question 51. So we're supposed to find the indicated limit if it exists still. So as you see on the whiteboard, as the limit x approaches 0, x squared minus x over x. So again, if you substitute 0 into the equation, you will get 0 squared subtract 0 over 0. So the square of 0 is 0, minus 0 is 0, over 0 is 0. So, sad face again, we must interrogate the function. So as you see, it is not difference of squares, but you're able to factor. So x squared over x can be also written as x bracket x subtract 1. So you're able to cross off the x's, so now you are left with x subtract 1. So now you're able to substitute 0 into your new equation. So you do 0 minus 1. So as the limit x approaches 0, your limit is -1. So therefore, the limit is -1. Alright, so on to question 60. So the question asks, if the limit x approaches 4, is there a limit at x minus 4 over the square root of x minus 2? So if you put 4 into the equation, you're going to get on the top 4 minus 4 over the square root of 4 minus 2. So on the top you're going to get 0, 2 subtract 2, so you're going to get 0 over 0, which we all know is sad. So that means we need to interrogate the function and find the actual value. So in the questions before, we were doing different ways to get the answer when we got 0 over 0. So there was difference of squares, and then the last one we were common factoring. So this one is probably the hardest one, and it's rationalizing. So you're going to put the conjugate in. So on the top you're going to have, which is the square root of x plus 2. So on the top you're going to have x minus 4, and then the square root of x plus 2. And then on the bottom, the square root of x minus 2, and then the square root of x plus 2. So I put a bracket down here because this is the part that we're going to focus on. So the 2 square root of x's, another way to write that in exponent form would be x to the 1/2, and since there's 2 of them squared, and then the 2 2's, the minus 2's right there, so -2 squared. So that's what that would be if you FOILed it all out. And what you're going to do, so you use exponent law, so you multiply. So 1/2 times 2 is just x, and then 2 squared is just 4, so x minus 4. So we're going to put that back into the equation. So like as the bottom, so the limit x approaches 4, it's x minus 4, and then the square root of x plus 2 over x minus 4. So now we're able to cross out the 2x minus 4, so we're just left with the square root of x plus 2. So now we're going to substitute 4 back into the equation, and so as the limit x approaches 4, it's the square root of 4 plus 2, which is 2 plus 2. So the limit as x approaches 4 is 4. So therefore the limit is 4. Thank you for watching my video, and I'm hoping I helped you guys out with limits.